Dr. Mohga. Today we're going to be talking about dispersion of light. In this lesson, we need to understand that dispersion of light is illustrated by refraction of white light, not any color or ray, white light by a glass prism, and the 7 colors that are shown as visible spectrum as per their frequency and their wavelength. So dispersion of light by a glass prism. White light has all the 7 colors, which we summarize them as ROYGBIV: red, orange, yellow, green, blue, indigo, violet. You need to learn their order. When white light enters a glass prism, it's both refracted and dispersed. Refraction, which we've taken before, occurs when light slows down as it enters a denser medium from air. So each color in the white glass has a different wavelength and therefore is refracted by a different amount. Violet has the shortest wavelength and the highest frequency. So always remember that frequency and refraction are the same. The more the frequency, the more the refraction. And of course, you know that frequency and wavelength are inversely proportional. So the higher the frequency, the less the wavelength. So red, which is the one on top in the image, has the least refraction and the least frequency. So this one has the least frequency and the least refraction. Okay, violet has the most frequency and the most refraction. Since it has the most frequency, it will have the least wavelength. And since red has the least frequency, it will have the most wavelength. Okay, so red having the longest wavelength, least frequency, least refraction. Violet having the shortest wavelength, most frequency, and most refraction. So this happens in the refraction side, and then later on, the separation of color is known as dispersion. So here is where refraction happens, and here is where dispersion happens. And in dispersion, the colors get separated, and they get refracted again as they leave the glass prism as a visible spectrum. So as a result, we get a colorful band of light or spectrum showing different components of white light arranged from red to violet. Dispersion happens because the refractive index of glass varies slightly for different wavelengths, and this is what we call material dispersion. Here's an example. White light passes through a glass prism and forms a spectrum on a screen. Why does red light refract less than violet light as it passes through the prism? We're going to say that red has a longer wavelength, lower frequency, so lower refraction. So the refractive index of glass is lower for longer wavelengths, so red light bends less than violet light, which has a shorter wavelength and is refracted more strongly. Difference in refraction angles leads to dispersion of white light into visible spectrum. Another example, a ray of violet light enters a glass prism with refractive index n is 1.53. For violet light, calculate the speed of violet light in the glass. We already know that the speed of light in vacuum is 3 times 10 power 8, and this you have to memorize. Now, the equation for it is that the speed is equal to the speed in vacuum, which is constant, over what? The refractive index. So using this equation, speed in vacuum is 3 times 10 power 8 meter per second. Refractive index is 1.53 as it was given to me in the question. So the speed of violet light will be 1.96 times 10 power 8. And do not forget the unit. It's still speed, so meter per second. Next, we have the electromagnetic spectrum itself. We have already done that, but let's fully finish this part. White light is made of many colors, different wavelength, different frequency. Their order is red, orange, yellow, green, blue, indigo, violet. And where the violet has the shortest wavelength, highest frequency, and accordingly highest refraction. Red has the most wavelength, or highest wavelength, longest wavelength. As you can see the wavelength here is the longest. Okay? And it has the least frequency, and it has the least refraction. So by frequency, violet is the highest, and by wavelength, red has the longest wavelength. That's all for today. If you have any questions, please let me know. Have a good day.